Second time we look at factoring special products, we're still looking at the difference of squares, or the difference of two squares. You might hear it as our book calls it the sum and difference of squares, but really it's the difference of squares, or two squares. Perfect square trinomial positive and perfect square trinomial negative. Really it's a trinomial, and you have a perfect square on the outside, you have a perfect square on the A term, perfect square on the C term, and then your B term will determine whether it's plus or whether it's minus. Now let's take a look at some examples, and we'll start off with the difference of squares. So if we have something like m squared minus 9. So first of all, anytime you see this situation where you have a term and a B term, or a term and a C term but no B term, and you see a negative in between, then you guys start saying, this could be the difference of two squares. So you look here, is it a square? You look here, is it a square? In that case, if it is, you're not going to have a middle term. So anytime they have to be mirror images of each other, except one has to be plus. So this is m plus 3, and this is m minus 3. And so in that situation, when we factor back, all right, this is going to give me a positive 3m. My outside is going to be a negative 3m. So therefore, I will not get a middle term. Now let's say we have an a term with it. And so instead of having 1 as our a, let's say we have a 49 x squared, right, minus 81. So again, anytime I see a binomial and I have an x squared term and I have a c term, I look, are they all squares? This one's a square, this one's a square, that one's a square. And if that's the key, so the more knowledge you have of squares, better off you're going to be with this. As soon as I see that, I take the square root of the first one plus the square root of the second one, right, of your C term, and again I multiply it times the square root of the first one minus the square root of the second one. And again, the middle term here will cancel. We get a plus 63x, we get a negative 63x, and they both cancel. All right, they cancel each other out, so we get back to 49x squared minus 81. Now sometimes you have to factor first to get to the difference of two squares. So in this example, we have something like 12 minus 27x squared. So again, anytime I see a situation where I have an a term and a c term, now again, this is not in standard form, but we're going to just leave it like that because it's going to be easier to do. I say, okay, is there a number that I can factor out of here? And the answer is yeah, I can factor out a 3. And look what happens after I factor out a 3. I get 4 minus 9x squared, which now is the difference of two squares. So now what I end up with here, is 3 times square root of the first one plus the square root of the second one, times the square root of the first one minus the square root of the second one. Right, so I have, again, the difference of two squares. So factoring out a number might get you there. And understand, problems are set up a lot of times for this stuff to work. So recognizing the difference of two squares is of the three things is the most important. The other two, if you don't recognize, you can still factor them and still get to the right solution. If you don't recognize the difference of two squares, you might think it's just unfactorable. But again, you could go to the quadratic formula if they're asking you for to solve the quadratic by factoring, but if they're just asking you to factor it, you have to be able to recognize those. Now let's take a look at the other two here. Let's say we have something like x squared. Okay, we'll look at one with a 1 for minus 8x plus 16. So again, anytime you get a trinomial and the last term and the first term are squares, then you look at, okay, am I going to get this middle term here? And this situation, it's going to be x minus 4, right? X plus, or sorry, x minus 4x, sorry, screwed that up there. It's going to be x minus 4 and x minus 4. Right? Now, again, what you look at here, square, square. When you take the square root of this, double it, and doesn't equal this one. And if that happens, then yes, you have a perfect square triangle. If it's negative, they'll both be negative. If it's positive, they'll both be positive. Now, this can also occur when you have a term, say like you got 9y squared plus 60y. plus 100. Now again, what I would do is you look at, okay, you take the square root here, which is 3y. You take the square root here, square root of 100, which is 10. 10 times 3y is 30y. If I double that, will I get 60y? And the answer is yes. So yes, I do have it. And then, so what I look at is this, I take the square root of the a term. All right, my signs are both plus, so I'm going to put plus, and I take the square root of the c term, and there we go. That is the perfect square trinomial, and that was positive. Now again, sometimes you'll have the situation where when you first get the problem, and say we have 2x squared minus 12x plus 18. So if I have a situation like this, again, I can factor out a 2. This is positive, or this is 2, 2, 2. So I can factor out a 2. And after I factor out the 2, look what happens. I get x squared minus 6x plus 9. Now I have a perfect square trinomial, and it happens to be negative. I recognize that. Take the square root of this, which is 3, double it, equals 6. So yes, what I end up with here is x minus 3, and that is squared. Right. Now again, if I was solving this using the difference or using the zero product property, I only have to do it once. And so actually the answer here then would be 3. Now you may get a situation where you have to factor out a negative. So let's say I have 3x squared, negative 3x squared, minus 18x, minus 27. We want to try to keep this a term positive. It makes it easier when factoring. So in this case, I'm going to factor out a negative 3. And look what happens when I have left. I end up with x squared. I've got to change all my signs. Plus 6x plus 27. And now again, take the square root of this. Or it's not 27. We'd have, not 27. We'd have 9. So that we get back to 27. Alright, so right here would be 9. Now let's look what we got. Take the square root of 9, it's 3, double it, it gets you 6. So our final answer here would be negative 3 times x plus 3, and again that would all be squared. Okay. So that is factoring special products. So it's the second time we've looked at that, and so hopefully you'll start to recognize it more, especially the difference of two squares. Again, if you don't recognize it, you can still factor. If you're solving the equation, you could still use the quadratic formula and still get to the correct answer, but it helps to recognize these things as you're